Right. Okay. Now let's start the chemical calculation nights, day 7. Right. So today, Buddha, we are going for a different area. This is very, very important. The entire lesson build up on this. So most of the students, they find difficult in this area. So that is redox reaction. Last week, I explained you what is oxidation, what is reduction, what is redox today. Redox mean, if I write reduction and if I write oxidation, if I add both together, okay, if I add red of this and ox of this, and I will get redox. What do you mean by redox then? Reduction and oxidation reaction. That is only known as redox. Redox is the one of the most famous thing in chemistry. So when you speak about redox, Putta, right? When you speak about redox, in the redox part, okay, in the redox part, again, always there is a substance. We'll say there is a substance called amine, that the A substance is there to release the electron. Then there is another substance called B, which is there to accept these electrons. And always a person will release the electron, another person will get the electrons. This is known as redox reaction. Okay. In redox, we write oxidation reaction and a reduction reaction both. Okay. Oxidation reaction and a reduction reaction both. Finally, we add that to write the complete reaction. Okay. First of all, we'll see. Again, certain things you have to remember. Now, today we'll see what are the reduction reaction scale. First of all, today we'll see what are the reduction reaction. Carefully observe. Reduction reaction. These are easy things. Don't get panic. Under reduction reaction, the first thing is, we'll think MnO4 minus becoming Mn2 plus. Okay. You can see the charge. What has happened to the charge? Okay. Now, again, first of all, there is a thing called Puta. To check the oxidation number, there is a thing. Chuttak, I will tell about that. Right? We'll say MnO4 minus. We'll think MnO4 minus. If I want to check the oxidation number of manganese, Mn, what you have to do, you can remember normal oxygen's, what is the oxygen's valency? Oxygen valency is 2. Therefore, we take oxygen's oxidation number is minus 2. One oxygen's oxidation number is how much? Minus 2. Then here, how many oxygens are there? Now I have to put a box like this. If I use a box like this, you can see one oxygen's oxidation number is minus 2. How many oxygens are here? 4 oxygens are here. Then minus 2 into 4 is how much? Minus 8. Then the final charge of the ion is how much? Minus 1. If I want to put minus 1 here, how much should be manganese? These both addition should be only this charge. Then what should be the manganese oxidation number? Plus 7. At the moment, just know this. How to find MnO4 minus manganese oxidation number? Did you understand how to find the manganese oxidation number? Because if you add these two, you should get minus charge. That part is clear? Good. Now, Puta, tell me what is the oxidation number of this manganese? This manganese is in what oxidation number? Plus 7 oxidation number. What is the oxidation number of this manganese? This manganese 2 plus charge. Therefore, this oxidation state is plus 2. So can you see what has happened to the oxidation number? It has reduced. Oxidation number reduced mean we call as a reduction. Oxidation number has reduced mean what we call? It's a reduction. So oxidation number has reduced, therefore we call this as reduction. Can you understand this is a reduction reaction? Okay, well done. But you have to remember MnO4 minus becoming Mn2 plus killer, you have to remember. You have to remember what? You have to remember MnO4 minus becomes Mn2 plus. That you have to remember. Next, I will give another thing. You have seen MnO4 minus before in your life. Okay. Now, if I give like this, Cr2, O7, 2 minus. Remember, Buddha, this one goes to Cr3 plus scale. You have to remember. You have to remember. There is no other choice. You have to remember this. Right? Again, Cr2O7 2 minus. Come on, let's see what is the oxidation number of chromium. Cr for chromium. Cr2O7 2 minus. Let's see. One oxygen is how much? Come on, speak. Minus 2. Then 7 oxygens. Minus 14. Then I want to get minus 2 as the final charge. Then what should I write here? Plus how much? Plus 12. Then only this will be equal to minus 2. Because these 2 minus, then it should end with minus 2. Then plus 12 means how many chromiums are minus plus 12? How many chromiums are here? 2 chromiums. 2 chromiums are plus 12. Then 1 chromium is how much? 1 chromium is plus 6. 1 chromium is plus 6. Then I can write like this. Okay. This chromium is in plus 6. This plus 6 chromium is going for what? Plus 3 chromium. Can understand that? Okay, plus 6 chromium going to plus 3 chromium. But if I balance this, there are Cr2 no Buddha. Then if I write 2 Cr3 plus, if I write 2 here, if I write 2 here, what will happen? This plus 3 will go for what? This plus 3, 1 chromium, both the chromium will become, come on speak, plus 6. In this, both the chromium will become plus what? Plus 12. Both the chromium plus 12 will already be known. Is plus 12 plus 6. Plus 12 going for plus 6 mean what is that? Oxidation or reduction? Reduction. So did you understand this part? Hurry. Puta, but remember this oxidation or reduction without checking the oxidation number also I can tell. Now you don't know to say oxidation number. But without knowing, if you just imagine you don't know oxidation number anything, still I can tell it's an oxidation or reduction. I will tell how to tell that. First of all, write all the necessary things. Still these are not balanced yet. Right? This, right? Reduction, half reaction kill, right? Reduction, what reaction? Half reaction. Reduction, half reaction. Sata gala write this. Whereas Cr3 plus mean 3 plus. No? Therefore, their oxidation number is plus 3. 2 Cr3 plus mean plus 3 are, there are 2 plus 3, then plus 6. Now, are these things okay? MnO4 is going to Mn2 plus Cr2. So using this also, using this we can see this is a reduction half reaction. Okay, without checking the oxidation numbers, how to check whether it's a reduction reaction? Now still I am speaking about reduction reaction. You have to remember this, guys. MnO4 minus go to Mn2 plus Kl, you have to remember. Cr2O7 2 minus going for Cr3 plus Kl, you have to remember. Right? Hurry. If you couldn't write anything, Taggala, you can complete using the recordings. Huh? Right. Now stop. Now still I am not done with the work. This is only half work is done. So I have to complete the full work. How can I complete the full work? I have to balance this entire thing, Puta. Now I will rewrite this again. And carefully observe how to balance this full thing. Now Puta, just imagine you are a person, you don't know anything about oxidation number. But you know only one thing. In reduction, again, you know, in reduction process, MnO4 minus goes to Mn2 plus Kl, you know. That one you should know. Then how should I balance this, Puta? First, see how many oxygens are here. First, we start balancing with oxygen. How many oxygens are in left side? 4 oxygens are in left side. If 4 oxygens are in left side, I have to put 4 oxygens on right side. No? How we add oxygen to right side? We add as water molecules. So I have to add 4 water molecules. Is it clear? I have to add oxygen as what? Water. So I have to add how many water molecules to get 4 oxygen? I add 4 water molecules. If I add 4 water molecules only, I get 4 oxygen for that side. Now oxygens are balanced. Then next thing come to, then what is excess there? Hydrogens are excess. How many H plus are excess here? 2 into 4, how many H are here? 8 H are here. So that 8 H, I have to put in left side no, to balance it. Then I have to balance H again. Then 8 H plus I have to include here. I have to put those H as H plus. So for everything clear? Now, just imagine you are a person who you don't know anything about oxidation number. So easy method to balance this is you can balance the charges. Again, remember in an equation, the left side charges should be equal to right side charges. So if we come for the left side charges, how many plus charge are here? Plus 8. This one minus how much? Minus 4, maybe minus 1. Is it only one minus is there? Who's it minus 4? How many minus are there? Only one minus. Then plus side 10, minus 1. Can understand? This 4 is the oxygen 4. Okay? Come here. Then when you come for this side, there is what? Only plus 2 is here. It means, Buddha, this is plus 8 and minus 1. What is the total charge here? Plus 7. Here plus 2. So can you understand here charge is excess. Therefore, I can balance the charges only by adding electrons. What is the charge of electron? Minus charge. So where should I add the electron? For this side, this is right side, this is left side. Where should I add the electrons? To the left side or the right side? I should add the electron to left side. Why? Because they are plus 7. If I add minus charges, plus quality will start to reduce. Plus will start to reduce. So I have to reduce this up to how much? Plus 2. Why? This side is plus 2. So this side also should be plus 2. So how many electrons I have to add for this process? 5 electrons. If I add 5 electrons, minus 5, then finally, if I add 5 electrons, then minus 5 plus 7, finally it becomes plus 2. So both sides are plus 2, then okay. This is known as what? Redox. Okay, in redox reaction, this is reduction half reaction. This is a full reduction half reaction. Did you understand this part? Okay, let's try another thing. What, Putha? Why this half reaction? Because these reactions with electrons, you can see the electron. If you see electrons, normally in a reaction, we can't see electrons. If you see electrons in a reaction, we call those reactions as half reaction. Right. You're asking why this is not a full reaction? Because you see electrons. Second, second one, we'll say, wait. Now, if I put Cr2O7 2 minus, this Cr2O7 2 minus will go to which one? Come on, speak. CR, CR, yeah, what? CR, CR7 में what? CR, CR3 plus. So I have to balance the number of chromium. Here, two chromiums are here. Therefore, I have to put two chromiums here. Right. Now I have to balance the oxygen molecules. No? Come on, guys, please help me. How many oxygen molecules I have to put? Sorry, Shik. How many water molecules I have to put? 7 water molecules. For which side? Right or left? Right side. Well done. How many water molecules? Come on again. 7 water molecules I have to add. If I add 7 water molecules for this side, what should I do? I have to add how many H plus molecules for that side? 2 into 7? 14. Then I have to add 14 H plus molecules for this side. Right? Then I put plus. Now we'll balance the charges. Tell me the total charges here. Now we'll see whether you know addition and subtraction. Tell me the total charges on left side. Yabang. Tell the total charges on left side. Plus 12. 14 plus 14. 14 plus me. This plus charge, how many plus charges are there? 14 H plus are there. It means, what do you mean? 14 plus charges. 14 plus charges and how many minus charges? Only 2 minus. 2 minus means, what is the number here? 1. Then only 2 minus charges there. 2 minus and plus 14 is how much? This side charge is plus 12. What is the charge of this side? 3 plus into 2. 2 into 3 plus will be plus 6. Now which side excess charge? For the excess charge, put the electron. How many electrons I have to put? 6 electrons. Then add 6 electrons for this side. Easy neither bad. But you should remember Cr2 minus go to Cr3 plus. Okay, that you should know. Hurry. Hurry. Only you have to remember this. This one goes to this thing. Other one automatically you can balance. Right. We'll balance another thing. Hurry. Now two things are okay. Hurry. We'll go for another one. We'll think Fe3 plus going to Fe2 plus. Hurry. What should I do here? Fe3 plus going to Fe2 plus. What's happening here, Buddha? Should I balance oxygen? Should I balance hydrogen? Nothing. So I have to just put the electron. Now what is the charge of this side? Plus 3. What is the charge of this side? Plus 2. In order to balance, where should I put the electron? For left or right? For the dance karno, right? So which side I have to put the electron? Left side. Why? Excess charge in left side. So how many electrons I have to add for left side? 1 electron. Well done. Subject now understood, no? This is the thing. Hurry. Sata Satagala. Write it beautifully. Before you couldn't write? I should keep the space in. Write this. These things are nothing for you. No need to write. If you're thorough in this, no need to write. It's fine. They are nothing for you all, right? Okay. You people write. It's not nothing for you. It's everything for you. You write this. Hurry. Nothing. Right? These are easy. But now itself, I'm training you. Still, we didn't start unit 3. But we are training you for this. Because when we start unit 3 will be nothing for you. Right? Hurry. Huh? Right. Are these things clear? Right. Put a Tattagala, right? හරි. Okay. Right. Okay, okay. හරි ඇති. Enough. Understand properly. Don't mix the things. Puta, you have to, if there are numbers in front of the element, if in front of the compound only, you have to multiply that. This is 1 mean 1 into -2. Don't go to multiply with this 7. Okay, you can make mistakes like that. Hurry. Next thing, if I give another thing like this, we'll see. Fe to O3 becoming Fe. Right? I want to write the half reaction for this. Right? Fe to O3 becoming Fe. Now, how will you write this? Right? How will you write this? Then, first of all, I have to balance what? Oxygen. So, what should I do? How many? First of all, balance the ion. 2 Fe, then put 2 Fe. How many oxygens I should write? I need 3 oxygen. Therefore, I have to add how many water molecules that side? 3 water molecules. If I add 3 water molecules, 3 H2O on. So if I write 3 H2O there, how many H plus I should write here? 6 H plus. Now, what is the total charge in left side? Plus 6 charge. What is the total charge on right side? 0. කොහින්ද plus 1 එකක් ආවේ? නිකන් වවුරුත් නැත්තම් plus 1 කියලා හිතුවද, right? This. Who is there? Nothing. Nothing means 0. So here, then I have to put this side also to 0. No? Can understand? This side is plus 6. This side is 0. So I should make this one also to 0. No? Then I have to add how many electrons, Buddha? 6 electrons. Can understand? So you should not write any half reactions like this. Very easy. Hari sata gala right. We'll see how to add the half reactions even next week. We'll see. Now, what I told for these things? Reduction, half reactions. Why we say reduction? Remember, if you write the electrons in left side, these are reduction. Okay, these are reduction reaction. If you write the electrons in left side, those are reduction reaction. We'll see. Then if you write the electrons in right side, oxidation reaction. All right, good. Now we'll think like this. We'll go with this one. Na? I'm thinking. SO3 2 minus is there. Becoming SO4 2 minus. You don't know anything about this. No? You don't know this oxidation or reduction. You don't know anything. We'll balance it. How to balance this? Where are more oxygen? Right side. Who are less oxygen? Left side. So where I should add water molecules to left or right? Come on, speak. To the left side. Why? Less oxygen for this. So I have to fill oxygen to here. How many oxygen molecules I need? 1. Then how many water molecules I should add? 1 water molecule. If I add 1 water molecule to this side, how many H plus I have to add for that side? 2 H plus for this side. Everything clear? Now let's balance the charges. What is the total charge here? Tell total charge. Tell ban total charge minus 2. What is the total charge here? Minus 2 and plus 2. How much? 0. Again, this side is minus 2, this side is 0. I can balance the charges only adding electrons. No? Then where should I add electron? To the left side. If I add the electron for left side, what will happen? Minus value still increase. No? Minus 2 become minus 4, minus 5. So I have to add which side? Right side. How many electrons? If I add 2 electrons, what will happen? This side also charge will be minus 2. This side also minus 2. This side also minus 2. Remember, in an equation, total charge of the both sides should be equal. Put understood? Understood, no? Sorry, very good. So, did you understand now? Electron has come which side? Right side. Then what is this? What type of reaction? Oxidation reaction. Even if you don't know oxidation number, still you can say it's oxidation reaction. Hurry. Then what is this? This is oxidation half reaction. Now beautifully write this. Put the who told time finish? Who said? Time finished? No, if you tell time finish, then we'll finish. Go ahead, finish. 8:34. We have 1 minute. Hurry. Maximum even a minute we have to use. Hurry. Right. Okay, see this. You go home and write this. See this. But remember these things, you should know. SO3 2 minus can go for SO4 2 minus. Those things you should know. We'll think I minus going to I2. I minus going to I2. How should I balance this? I have to put, first of all, I have to balance the ions, number of molecules. 2 iodine there, here 2y. Then what is the charge in this side? -2. What is the charge here? 0. 0 no charge. So to balance, which side I should add the electron? To left or right? Come on, guys. Right. How many electrons? 2 electrons. What type of reaction is this? Oxidation. Oh, understood? No? Is it a big thing? Okay, for this lesson, normally most of the people are scared. Easy, ne? Okay, nothing to get scared. No? Right. Right. Okay, right. So we will go into it in the next class. That's it for today's night. Then good night. Okay.